good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelia Suvinda with another video. Alright, so in this video, we are going to do some example questions on the chain rule, which is the composite functions. We're going to do some examples in this video. So, as I said previously in the videos, you can practice these questions beforehand. And lastly, I'd like to thank for the support. The channel is still growing, and I've seen that for the past days I haven't been consistently posting, but this I'm going to post today. I hope that it will at least help you in some way. Alright, let's get on with the video. Let's start with question 1, which says, differentiate the following with respect to x. So WRT means with respect to x. For your a, you have y is equal to 5 minus 2x raised to the power 3. Then for b, you have y is equal to 1. We divide by 1 minus 3x minus 2x squared raised to the power 3. So in this case, we can start expanding this bracket, also expanding that bracket. It will take us a long time. That's why we learned about the chain rule, which helps us find or form combined functions. And then from the combined functions, we can now differentiate something that is easier in a way faster method. So in this, on this question, which is question 1, we are going to use the chain rule, dy dx is equal to dy du multiplied by du dx. And then for question 2, we are going to use the core, that formula that I showed you about the core. So in this video, I'm only going to do question number 1. Okay? So for a, you have your y is equal to 5 minus 2x raised to the power 3. The first step is to say let u be equal to whatever is in the brackets or the parentheses, which is 5 minus 2x. And then you say your new y will be equal to whatever has remained here. Okay? So in place of the bracket, we are going to put u, but remember that there's a power 3, so use the power 3. So I formed two functions, one in u, y, one in u, one in y. Okay, you can see that. Then we differentiate each one of them. We're going to say du dx is equal to minus 2. Okay, derivative of a constant is 0. Derivative of this, have a power 1 multiplied by a negative 2 will be negative 2. Then power 1 minus power 1 is the power 0. Anything in the power 0 is 1. So if you just have a variable like this, it has no power that you can see. There is an invisible power 1 here. And the rule for this, or not the rule, the easiest way to differentiate it is just get the number that is in front of that variable. That's a negative 2. Then your dy du is equal to a 3u squared. Dy dx is equal to a dy du multiplied by your du dx. So in this formula, it's sort of like, in a way, your du and your du you cancel out, and then you remain with dy dx. That's the memory mnemonic. But mathematically, it is wrong. A derivative, which is du, and du cannot cancel out. But a way that we remember is we say in such a way that they cancel out. But mathematically, when you are answering questions, they cannot cancel out. Okay, so we substitute. Dy du is your 3u squared multiplied by your du dx is your negative 2. We multiply the numbers. 3 multiplied by negative 2, it will be equal to a negative 6u squared. Therefore, your dy dx will be equal to negative 6. U was a 5 minus, so u was a 5 minus 2x raised to the power 2, like that. So that's your final answer for A, using the chain rule. Okay, so let's go to B. We answer B. For B, we have y is equal to 1, you divide by 1 minus 3x minus 2x squared raised to the power 3. So when you have such, first of all, a function where now the variables are a denominator like this, you can't differentiate them in this form. You have to differentiate them in their linear form. So for us to differentiate them in their linear form, we take it up. Okay? So y is equal to 1 minus 3x minus 2x squared. When we take it up, it has a power 3 here, it becomes negative 3. So there's a positive 3, it becomes a negative 3. At least in this way, we can now proceed. We're saying let u be equal to 1 minus 3x minus 2x squared, and then y will be equal to what has remained, u to the power negative 3. Your du dx, okay, we're differentiating u with respect to x, will be equal to a negative 3, and then this is for derivative of a constant is 0. Here I said just get the number that is in front of the variable negative 3. Then now if it has a power 2, you say 2 times negative 2, okay, the number that is in front, which is negative 4, and then the power will lose 1, it will just become x. We don't write x to the power 1 because here there is an invisible power 1 already. Okay, and then we have dy du is equal to negative 3 u raised to the power negative 4. So negative 3u raised to the power negative 4. What have I done? Negative 3 is multiplied by whatever is in front of you. In this case, it's a positive 1. So it becomes negative 3. And then negative 3 minus 1 will give you negative 4. And this is the point where a lot of students make mistakes. Negative 3 minus 1, someone may write negative 2, which is wrong. If you use the integers right there, you are going to find negative 4 if you know your integers. Okay, so your dy dx is equal to dy du multiplied by du dx. Your dy du is your negative 3u to the power negative 4. You multiply by your du dx is minus 3 minus 4x, in that way. And then to proceed, you're going to say that, realize that in the question there wasn't any letter u, there was only x. So let's substitute the u, where we said let u be equal to this, so the core, substituting the core, which is 1 minus 3x minus 2x squared. In this case, it's been raised to the power negative 4. Then you multiply by negative 3 minus 4x. I hope you can see that. So this is being multiplied by negative 3 minus 4x. So in this case, since we have already substituted, we can just remove everything. We are saying our dy dx is equal to negative 3 multiplied by 1 minus 3x minus 2x squared. The power negative 4, you multiply by negative 3 minus 4x. Like that. And then here we can see that there's a power negative 4. In your final answer mathematically, it's just best to leave your power positive. How can you leave that, how can you make that power become positive? You make it go down, okay? Because you make it go down because it's a negative power, negative index, then it becomes a positive power. So your dy x would be equal to negative 3. You multiply by negative 3 minus 4x, divide by 1 minus 3x minus 2x squared raised to the power, in this case, positive 4. What have I done here? So since the negative 3 minus 4x didn't have any negative power, I left it on top, and I did negative 3 multiplied by negative 3 minus 4x. And then the core, which is this part, had negative power. It went down and became a positive. Raised the power positive 4. And this marks the end of this video. Thank you so much for watching. Thank you so much for the support rendered. This has been Cornelius Subinda with another video, and bye-bye.